Hello. All right, so we're still in Unit 1 and we are going to move on to simplifying radicals. So radicals, what they do is basically they undo that repeated multiplication that we talked about in the last video. Okay, so I just want to kind of explain what this notation looks like whenever we talk about a radical or a root. Okay, that's just the symbol. All right, here, the symbol. Okay. Um, So this is not the number, right? This is not the number. This is, I'm just going to say not number. This is just basically the square root in this case. Okay, but it could be a different kind of root. It could be a square root, a cube root, a fourth root, and so on and so forth. So in this case, we are just talking about this symbol. Okay, symbol. All right, and then when we talk about the radicand, okay, the radicand is basically everything under that symbol or everything under the square root. So we're going to go ahead and say everything under the radical. Okay, so radical is a symbol, radicand is everything under the symbol. Okay, and when we talk about a radical expression, or here, let me just put a little arrow here. And that's whatever's underneath there. And then we talk about the radical expression. That's just the whole thing put together. So in this case, our radical expression would be the square root of a. Okay. So the reason I go over that is just so that if you hear me using those words, you know what it is that I'm referring to. Okay. All right. So both negative and positive numbers can be the solution of a square root. However, for the purposes of our class and in the Knewton software, we're just going to evaluate the positive solution for this specific section. Okay, so if there's already a square root here, you don't need to put plus or minus in front of it if that's something you've seen before. Okay, it's only when we're solving that we need to put the plus or minus. So if the radical is already there, we're just simplifying. Okay, so we want to compute the following. Now, remember I said that radicals undo repeated multiplication. So if this is something you don't know how to do in your head or you don't have your calculator on hand, I want to show you why the square root of 25 equals what it does. Because I can actually factor 25 down. 25 is the same thing as 5 times 5, right? So I have two copies of a 5 being multiplied together. Or in other words, this is a 5 squared, right? And because this is a squared root, right? Or our index, our little root symbol is a 2 when there's nothing written there. That means we need two copies of a number in order to simplify it, right? So this is the same thing as the square root of 5 squared. And we can think about that radical and that square canceling. So we just get a 5. Or you can think about it as, okay, I have two copies of a 5, so that 5 comes out. Okay, however you were taught, that's totally fine. I want to do the same thing on the next one. 121 is the same thing as 11 times 11. So again, because we have two copies of an 11, that 11 comes out of the radical. And since that's all that was under the radical, we have nothing left over, so we don't even have to write the symbol anymore. Our answer is just 11. Okay. Same thing on this one. Now this is just a little bit different because we have a subtraction, okay? And when we have a subtraction, we can't simplify this number and this number. We need to simplify that subtraction before we do anything. So I'm going to go ahead and do 300 minus 219, which is going to give me the square root of 81. And then 81, now we can go ahead and break down. Okay, 81 is a perfect square. It's the same thing as 9 times 9, right? And since that's the only thing under the radical, I can go ahead and say this is just going to equal 9, right? All right, same thing with the next one. I have 100 plus 44. That's going to give me the square root of 144. 144 is also a perfect square. It's 12 times 12. And again, I have two copies of a 12 underneath my radical since it's a square root, a square, and my double copy cancels. So this just equals 12. Okay. Now I want to show you off to the side really quick, and we'll get into this more later, but I just want to show you, if you didn't know that 144 was 12 times 12, so I'm just going to do a little side note here, and you were trying to simplify the square root of 144. Okay, maybe you don't know that that's 12 times 12, but you see that it's an even number. And so you're like, you know what? I know that 2 goes into that. So 2 will go into 144 72 times. Well, 72 is also an even number. And so I know that 2 goes into that. So I can go ahead and divide that by 2, which would give me what? 36, right? And then 36, if I don't know that that's 6 times 6, I could keep going it with 2's, but I'm going to go ahead and stop there because we know 36 is 6 times 6. Okay, so notice here, I would simplify it the same way. Just like over here, I said, oh, I have 2 12s, so the 12 comes out. The same thing is true here. I have 2 2's, so that means I can bring out a 2. And I have 2 6's, so that means I can bring out a 6. So what I'm really doing is bringing out a 2 and bringing out a 6, which means I'm bringing out a 12 when I multiply those together. Okay, so if you know what the perfect square is right away, great. If this number is a little bit big and you're not sure, you can break it down to smaller numbers, and then again, for each 2 copies you have of a smaller number, you can bring them out, and then however many numbers you bring out, you just multiply those together. Okay. All right, so there's some practice problems here, so I'm going to go ahead and have you just pause the video, and then we'll go back over them here in just a second. Okay, good luck. All right, so I'm going to go ahead and go over the practice problems. On the first one, we add the 2 numbers together, and that gives us the square root of 169, which if you use your calculator, or if you know your multiplication tables, is the same as 13 times 13. So I have 2 copies of a 13, so that 13 comes out. I have nothing left under the radical, so it is gone. Same thing with number 2, I do my subtraction first, right, order of operation, which gives me the square root of 64, which should be 8. Now, if you're not sure that 64 is 8 times 8, I showed over here where you could take 64 and break it down by little numbers, like by 2, right? 2 goes into 64 32 times. 32 can be divided by 2 to get 16. 16 can be divided by 2 to get 8. 8 can be divided by 2 to get 4, and 4 can be divided by 2 to get 2. So notice, even if I break it all the way down to 2's, if I circle each pairing that I can pull out, notice I can pull out 3 2's. 2 times 2 is 4, times another 2 is 8. Okay, so either way, you'll get the right answer. I just wanted to be sure and just kind of highlight that. So that is pretty much all of simplifying radicals. So easiest section of your life, right? So that one is now going to be due. Please let me know if you have any questions.